Hi everyone, welcome back to my dining room. So we're going to take a look today at solving equations using logarithms one more time. Now the last time that we were working on solving equations using logarithms last week, what we did was we isolated the exponential term, got this guy all by itself, rewrote the equation using logarithms, and then solved that equation. That doesn't always work. That's not always an option. So what we're going to look at today is another way to do it that doesn't use exactly that approach. And it's a way that you can use for all equations with variables in the exponent. So first off, if your variable's in the exponent, like right here, 10 to the 5 plus 2x plus 820 equals 49,600. We're working with exponents. We're going to have some big numbers sometimes. It's okay. If your variable is in the exponent, logarithms are going to come into play. But before we can use logarithms, we need to get this exponential term by itself. So I'm going to subtract 820 from both sides. Okay, and that's going to give me 10 to the power of 5 plus 2x equals 48,780. Okay, now, so far, this is exactly the same as what we did last week. But right now, we're going to do something a little bit different. Instead of rewriting this as one logarithmic equation, what we're going to do is we're going to take the logarithm on both sides. We're going to use log base 10 because all the calculators that we have out there have log base 10. So we're going to do the common log of this left side, 10 to the 5 plus 2x, and we're going to do the common log of that 48,780 that we just had. Okay. The rule is with algebra, you can do whatever you want to any equation as long as you do the same thing on both sides. Taking logarithm is no different. So now, here's where it gets kind of cool. First off, just like we talked about last week, this is a number. Now, it's a decimal. It's a pretty messy decimal, so we're not going to mess around with it just yet. But we're going to treat this like a number because it is. Now, over here, this expression looks pretty messy, and it is. But there's a pretty cool property that exists without logarithms. If you have a logarithm, base b of a raised to the power of n, that's equal to n times log base b of a. So what that means is if there's an exponent inside the logarithm, everything in the logarithm is raised to an exponent, you can bring that exponent in front of the logarithm. So we can take this n that's inside this log and write it out front of the whole thing. So here's how that works here. Okay, I'll have 5 plus 2x, okay, all grouped together, times the log of 10. Now over here on the right side, this is still going to be log of 48,780. Okay, but this is going to be a whole lot easier of an equation to work with because here's something else that's interesting. Take out your calculator, okay, and do log of 10. You get 1. Okay, so the log base 10 of 10 is 1. So this whole expression right here is just 1. So this 5 plus 2x that's getting multiplied by 1, anything times 1 is itself. So we have 5 plus 2x equals the log of 48,780. Now, once again, this is just a number. It's a constant, okay? I could find this on a number line. We basically have a two-step algebraic equation now. We'll subtract 5 from both sides, and we'll have 2x equals log of 48,780 minus 5, and then we'll divide both sides by 2. So now we have x equals log of 48,780 minus 5 all over 2. Now when we go to the calculators, we need to keep in mind this division bar, yeah, it says divide, but it also says group. So I need to put parentheses around this whole top Otherwise, we will get the wrong answer. So, calculator. Now, tell you what, I'll type it all in and then I'll show you what the screen looks like. Parentheses, log 48,780, close one set of parentheses, minus 5, close second set of parentheses, divide by 2. So when you type it all in, that's what it should look like. Okay, and we press equals, and we get about negative 1.55. Actually, negative 1.56. Negative 0.156. And there we go. So this is another approach that we can use to solve equations involving logarithms, involving exponents, I should say. We can take the log on both sides. Instead of writing the whole thing as a whole new equation, we just use a little bit of algebra, do the same thing on both sides. Now, let's take a look at a slightly different one here. Okay, we're going to skip example 2, and we'll go right over here to example 3. Now, we're going to use a lot of the same stuff on example 3 that we did on the first one. So I have 3 to the power of 5x minus 6 equals 2 to the power of 4x minus 1. Now, this has exponents on both sides. It's not a problem. We're going to do the exact same thing. We're going to start by taking the log on both sides. Okay, we take the log of the left side, take the log of the right side, and that's going to allow us to some mobility with those x's. So now what we have is the log of 3 to the 5x minus 6 equals the log of 2 to the 4x minus 1. Now, the whole reason that we do this is because there's this property that allows us to take that exponent inside the logarithm and bring it in front of the whole logarithm. So that's exactly what we're going to do right here. This 5x minus 6, now remember, we got to take the whole thing, the whole 5x minus 6 has to come out front. So I'll have the quantity 5x minus 6 times the log of 3 can do the same thing over here. Bring out the 4x minus 1. And I can have 4x minus 1 times the log of 2. Okay? Now, remember, log of 3, log of 2, those are constants. Those are just numbers. So treat them as such. Now, if you had a number outside a set of parentheses, you know that you would distribute. So I've got 5x times the log of 3 minus 6 times the log of 3 equals 4x times the log of 2 minus 1 times the log of 2. And just like we said on the last example, anything times 1 is itself. Now, one more time, a logarithm, this log of 3 and these logs of 2, those are just numbers. So treat them like numbers. I've got x's on both sides of the equation. I need to get them on the same side. So I'm going to do two things at once here. I'm going to subtract 4x times the log of 2 from both sides. And I'm going to add 6 times the log of 3 to both sides. Okay, now that's going to cancel these, and it's going to cancel these. So on the left side, I've got 5x times the log of 3 minus 4x times the log of 2 equals 6 times the log of 3 minus the log of 2. Okay? So now, next thing that I want to do, I need to get this x separated. I know that these look like they might be like terms. They both have x's and they both have logs, but they're absolutely not like terms. I can't just combine those two. But what I can do is bring out a factor of x. Okay? Both of these are multiplied by x. So we fall back on an old algebra skill and we do x times the quantity 5 log of 3 minus 4 log of 2 equals 6 log of 3 minus log of 2. And now look at this. We got x times a number equals something else. Divide both sides by that number. So what I'll have is x equals 6 log of 3 minus log of 2 all over 5 log of 3 minus 4 log of 2. Flip that up so you guys can see it. There you go. Now, keep in mind, when we go to the calculator knows order of operations better than you or I. So we need to absolutely be sure that we put parentheses around the whole top and around the whole bottom. Okay? All of this needs to get typed into the calculator exactly like this. Now, something else that's going to happen, when you push the log button on most calculators, it opens up a set of parentheses immediately. Make sure you close it in the right place. Okay, so give me a moment to type this in the calculator. That's going to fall. Give me just a moment. So open parentheses, 6 log 3, close parentheses, minus log 2, close, close, divided by, open, 5 times the log of 3, close parentheses, minus 4 times the log of 2, close, close. All right. So this is the whole big mess that you need to type into that calculator so that you can get the correct answer. Okay, and then we press equals, and we get about 2.168. Is that right? Yep, 2.168. So x is approximately equal to 2.16. And I just got a notification on my computer, so congratulations, you got to hear that as well. Now, guys, this is what it all comes down to. Okay, instead of rewriting the equation using logarithms, we just take the log on both sides. That allows us to use this new property over here. If we have an exponent inside the logarithm, the entire argument is raised to that exponent, then we can take that exponent in front of the entire logarithm. Okay, bring it out front, and then we work with it just like numbers, just like we do with regular old algebra stuff. Okay? All right, guys. There's an assignment loaded onto Teams. There's going to be a quiz on Friday. There's notes on this in Teams. Make sure you get your questions answered. The assignment's due on Thursday at 3:30. I'm going to post an answer key at 5 o'clock. Make sure you get your questions answered and get that assignment done before that answer key posts. You will not get full credit after that answer key posts. If you have questions, guys, email me. Use the chat feature. One way or another, make sure you get your questions answered.